So I think first we should add a sort of timer that will make the blocks drop automatically over time, one square at a time, because the drop input functionality is going to modify that timer to make it really fast, somehow ignore inputs and just go fast. But for now, let's have I think we will have now the game mode is spawning in the new quad, but I think I'll remove that from here and just have the player controller tell the game mode to do that. Also, pretty soon we'll need to start randomizing the configurations of the blocks within the quad, the different colors. But that won't be too bad, and we'll do that before we start doing matches. But for now we're just doing dropping. So when the player tries to move down and they cannot, then that is the time when the quad should become deactivated and a new one should spawn in. For now, I think we can just spawn in a new quad and leave those blocks where they are, and the quad references will be updated to the new spawned one. So I think that will be fine. So for now, I'm just going to try calling spawn new quad right here, but we'll probably need to consolidate this into a more logical function. But for now, let's try this. See what happens. There probably should be some delay too. We don't want it to be literally instantaneous, and maybe we do, but we'll see. But when the thing falls down, then it tries to move one more time, and then suddenly we have a new quad. So you could just press down, 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 and then suddenly here's a new quad. Rotate, it maintains its configuration, new quad. There's no matching happening yet, but that'll be exciting when we can do this and have all these blocks get cleared. It's a fun configuration. Okay, so now we want to make that dropping happen over time, like automatically, even if the player doesn't press any buttons. So as soon as the quad spawns, I think we'll start a timer. So we'll say, timer by function name, set timer by function name. And I don't know the best practices for implementing timers, if the function name should be parameterized or something. I normally just type them in explicitly, but who knows? I don't. So I'm going to make I guess we'll just have the timer call check move down. Oh no, it needs to call some other event or something that runs the same series of steps that the input action move down does, so that it does literally the same thing. So let's make a custom event called fall down one space. I could call it automatically fall down one space. That's a really long name, but maybe it's more descriptive of what is calling that event. That event gets called when time elapses. So, and I will create a variable from the game mode, which is time between automatic falls. And we'll make that a float and describe it as the time in seconds between the time in seconds after which the quad will automatically drop one grid space downwards. And I don't know what that actually is in the real game of Lumines, but I'll do like 1.5 seconds or something for now. I'm sure we'll tweak that later. But now we have the value to pull here. And we want this to be a looping action. And so it'll call that every time the timer elapses and fall down one space automatically. And actually, I don't think we want this to be looping, and I'll explain why. When the player presses the down arrow, this is a game designer decision. Like, do we want the timer to reset? So like when the player presses down and the timer was, almost about to fall one space, I'm pretty sure we would want the timer to reset so that it won't immediately fall two spaces. If the player happens to press down right before the timer elapses, then the player will move down two spaces, and that just feels like bad, game design, or it won't feel good to the player. They'll be confused about why it fell down two spaces. So I think we should reset the timer. So we'll just call this again when either of these events happen, and set the time again to the time between falls. And that should be good there. So let's see what happens now. If you just don't do anything, it's slowly falling by itself. And I'm now going to press the S key soon before it falls and see if that... Okay, I did it by myself, and it seems to have reset the timer so it won't fall two spaces, rapidly by itself. Right now I can press down as often as I want, but we may want to change that. I think that's fine though. So I think to implement the drop function, we're going to go to the game mode and add a new variable called like time between faster falls. That's not, a great name for it, but it's somewhat descriptive. So we'll make this like 0.1. That might be too fast or too slow, but that's the time that we're going to set the timer to in the player controller. When the player presses the, what did I call it? Drop. The drop input. What's going to happen is we're going to set this timer to, I guess we could do something like this. We'll have one more variable called the current time between falls, and that will be set to either one of these two values. We'll go ahead and default it to 1.5, but you should probably explicitly default that somewhere in the construction script of the game mode. So like, we'll set current time between falls to the default value of time between automatic falls, just so that will get updated if we ever change time between automatic falls somehow. And when either of these two events happen, we will set the game mode's current time between falls to automatic time between falls. Oh, well, no, there's one more issue. That's well, actually, you don't even need to have a separate call to set timer here. I think we can do like a boolean, like in the game mode, like B is quad dropping faster. And when that is set to true, which the drop input command will set that to true. So set is quad dropping faster. That will get set to true when the player presses the button. And when that is true, then we'll change current time between falls. I'm also going to do this. I'm going to call automatically fall one space. And then, based on get is quad falling faster. And then we branch and we set time between falls to one of the two values based on this Boolean. What this is going to accomplish is, one place where we call the function with a timer. We call where we set the timer or reset the timer with a new value. And I guess it's fine to do that, but I'm going to go ahead and do this. Get current time between falls. Set that here, that way it's not one or the other. If it came out of here, it would look a little confusing why it's not coming out of here, but if it's a completely separate one, then it's clear that it's not related to which of the two paths it follows. Either way, it's going to do this. And we'll set the time between faster falls like that. So if this Boolean value is true, then the current time between falls is going to be set to that faster value, and that's what's going to be input here to the next time this function will fire. This event will fire, rather. And if the player presses move down while they've already pressed the drop action, then it's not really going to have an effect. Or it will have an effect, but it should be negligible. In fact, we may want to do something about that, but for now it's fine. When this happens, when the block has reached the bottom, we want to set the Boolean to false again. So that the next one that spawns in doesn't also fall down really fast, right? That would be incorrect behavior. So this is false. And then that should be good. I think that's what we want. It's a little bit cramped. So we can see how this works. What is, oh, boot, there we go. So I'll review this in a moment if it actually works. So I'm going to press space bar, and it falls down rapidly, and a new one comes in, and it has this weird effect where it falls one more time quickly, which we don't really want that to happen. So we need to change something a little bit. Let's see here. What's happening that's incorrect here is the we're spawning in a new quad, and time between falls is still set to the faster falls value. So we just need to set that again back to the slower value. It's a little bit messy to do this again over here, but I suppose it's all right. Is this straight? No, it's still down a little bit. There we go. That's a bit of a weird little fix, which looks messier than I think it actually is, but that should prevent that weird quick drop at the beginning. There we go. I think actually the quick fall speed is too slow. We want to make it be even more rapid than this sound. Now when the floats get really small, I don't know if the logic starts to fall apart, like when an event timer is this small, if that affects the way, that Unreal handles, fractions of a second with, variable time steps. I don't know exactly if that float is too small of a value, but it seems to be falling a little faster now. One other thing about that is we want to, once the falling happens, we could even make it instantaneous. Like I want to find the middle ground between so instantaneous that you can't even see the falling action, and so slow that it's too slow for the player. They want to move on to their next brick. They want to move on to the next quad like really fast, right? But I can't do like 0.001. Let's see what 0.01 does, because it's going to be less than the usual like frame delta, like delta time for a single tick. So I don't know how that's going to work. It might be a bit uneven, but it seems pretty smooth. So maybe I'll go with that. Seems pretty okay. We also don't want the player to be able to move the brick once it's falling. Like right now we can rotate it and like translate it left and right while it's falling. It looks a little weird to be able to do that. I don't think that's what we want to have happen. So I think we should restrict the left and right movement and rotations while it's falling. We also need to think about splitting the quad vertically so in the real game, when you drop like here, the left half of the quad is going to drop down to the very bottom. But right now it's going to just spawn in a new quad right now. But the two parts right here below me right now should fall down all the way to the bottom. So that's one thing we're going to have to figure out how to do. That'll be fun. But one last thing about dropping right now. Maybe we should do that splitting now before we get into worrying about matching. But we need to restrict the player movement left and right and the rotations when the falling is happening. That's going to be really quick. All we need to do is go to the player controller and add some checks here. I'm going to go ahead and move down underneath the rotates, because the relative simplicity of the rotates on this top level graph should be matched with the relative simplicity of the moves, while this sprawling mess should probably be consolidated to other functions. But for now I'll leave it like that because it's not that bad. But when we have quad is dropping faster, when that is true, we don't want any of these to happen. So all we need to do is check the value of that and say, don't do these if it's falling fast. the reason why I'm not like doing an and boolean here is we don't want to have to worry about wasting, system resources doing these ray traces if we're not even in the right state to go forward in the case where this returns true. So let's not even waste the resources doing that. So all of these are going to check this Boolean value and only do their work if it's true, or if it's false rather. So I'm going to say get B is quad dropping faster. And I'm going to do a not Boolean here just because I like to have the significant result be the true. So like maybe that I've probably already broken that rule, but I just like the execution pins to go along the true path to get to like the significant result. So that means I need to make if they are not dropping faster, then true. So that's why I'm putting the not Boolean there. And I'll go ahead and put this in the middle and just reuse the same node. Hopefully that makes sense why I do that. So if it's not falling fast, then process input. Otherwise, basically don't process your inputs for movement and rotation if you're falling fast. So now we can't move left and right and rotate while it's falling, which is what we want, I think. So now we want to move on to splitting the quad vertically and having it fall. So that may involve some refactoring of the downward collision check logic. I think a good way to handle that would be to just, let's see. We could do some minor revisions to check move down and have it return, two Booleans, one for the left half and one for the right half of the quad, and stop the falling of one of them when that half returns false. And then once both halves have returned false, then we spawn in a new quad. That could work, I think. Let's go ahead and create some local variables called B left half can move down, since it's specifically down now, and B right half can move down. And we're going to return once at the end, and just be B. I don't know if I can call it the same thing. I don't think I would be able to. Yeah, so let's just rename this actually to B left half can fall or something like that, and B right half can fall. I want the top level output to have a more clear name. They both mean the same thing really, and they're both just going to get the results of the temporary variables, the current value of the temporary variables. And so this part is going to decide the result value for left half can move down or right half can move down, and then this part will determine the value for left half can move down. I'll just explain as I go. So we'll reintroduce the other nodes here, but these aren't going to be return nodes. They're just going to set the values of the local variables. So if it is valid and one of these two types, then that means the right half cannot fall down. So then we set B right half can fall to false. Otherwise, we'll set B right half can fall to true. I don't really need that redirect node. Just do it like that. And same thing here, except for it'll be left half can fall. And then the return here will be, like, once one of them has fallen and touched something underneath it, we don't really need to check it again. So if that becomes a problem, we can, have a branch or a switch or a boolean here to only check the ones that are still falling. But for now, we'll leave it like that. And you can close this and that and this. So now once this returns, it's going to give a boolean value for both of the left and right halves. So we'll need to deal with both of them individually. So this is going to be what happens when both halves have fallen, right? So I'll just call this like finish falling. I'll collapse this to a function, call it finish falling. And I can get rid of these and just use another reference to game mode. And I'll just write here, called when both halves of the quad have finished falling. So then I need to reconnect these before I compile, otherwise it's going to say it's broken. I need to set these to be the game mode and automatic falls time. So that should be, the same logic. I just put it in a separate function so that I can self-document what's happening. So when the left half is unable to fall down anymore, we just don't move it down anymore. So that means I need to separate the movements for the left half and right half. I could make an enum for this and have like 3 cases, or 2 cases. No, these be 3 cases. Move both halves, move left half, move right half, right? I guess I'll do that. I could have also just split the move down method, move blocks down 1 space. I could just make this into 2 separate functions, call one of them, move left half down 1 space and move right half down 1 space. Then just call the functions based on the result of this. Then I won't need a whole separate enum for one specific case. That's probably better. So yeah, I'll go ahead and save this, but I think I'm going to delete it if this doesn't pan out. If this, we'll see. So I'm going to change this from move the whole quad down 1 space to just move 2 of them down 1 space. Now that is perhaps a bit more duplication of code, but not really, so I think it's fine. So I'll make a new function called move left half down 1 space. and move right half down one space. And this is just going to move the left half of the quad down one space. I don't think this needs explaining really what I'm doing. I'm just moving the two blocks that make up the left half of the quad down one space. I'll go ahead and do a sequence, even though it's only going to be two things, maybe three including the return, but that's fine. I prefer things to go like downwards than to the right, because you can fit more on one screen if you have it kind of go downwards into a sequence as opposed to just stretching out to the right. But that's just personal preference, I think. I don't claim to be a master of blueprints by any means. So that's BL and TL, and now I just need to do the same thing for BR and TR for the other function. That's again holding control down and then left clicking and dragging. And there we go. So that's two functions to do what was once done in one function here. Of course, this looks a little more elegant with the for each loop, but no need to do a loop for two elements, I feel like. Because you have to make the array out of these two elements and then do a loop. It's like not really that big of a difference. Yeah, it probably would have been better to do that, but oh well. Now we just go back to the event graph, and based on the result of these two booleans, we'll call one or the other or both of those two new functions. So if both of them are true, if the left half and the right half can both move down, then we call both of them. So we could even call this function, which moves them all down at once, but no need to. This function is basically redundant to have if we have the left half and right half ones. So we can delete that function after we confirm that this works. I don't think this will introduce any like race conditions or anything, because anything that we need to do after it's finished falling, we can just do here. And when it's halfway fallen, we just won't do anything until it all falls down, like update matches and stuff, which we haven't even implemented yet, but I think it'll be fine to just do it all at the end. So if both of these were true, we do that. If only one of them was true, then we do just one or just the other. This is going to be perhaps a little bit strange looking, but I'm going to just do this kind of snaking thing here, which, you can be the judge of whether this looks terrible or not. It's basically like a switch statement, but not even close. So if they're both false, that means we have finished falling. If one is true and the other is not, then we do the appropriate one of these two function calls. We can just say if the left half one is true, then we can move the left half down one space. And then if the right half Boolean is true, we can just move the right half down one space. And if neither of them are true, which would be the only way you actually reach this branch, then finish falling. So we can probably just do this and erase this entire thing, but I'm going to leave it there in case we need it. Because if both of these are true, then this true statement will execute. If either one of them is false, then we'll jump down here. And if either one is false, that means only one is true, or neither of them are true. So first we check the left half one, then we check the right half one, and then if neither of them are true, this is the only time that this pin would execute. So I think we got a little bit overcomplicated there. Let's go ahead and see what happens now. If we just drop, let's see if it even works at all. Okay, that seems to work. And now let's see what happens if I drop here. Okay, it split properly. Let's see if it splits properly here. Okay. The splitting seems to be working. Kind of surprised it worked the first time. But, you know, I have made a Luminous clone in Unreal before, but I think the implementation that I'm doing this time is a lot better, just from having a bit more experience. I knew what issues I'd run into and how to better approach them. So, I mean, I'm not saying this is working perfectly, but it seems to be working as I expected it to, so that's good. Checking like the edge cases for the corners and getting caught on the wall, but it seems to be working fine. So that's good. So we can delete this bit here, and yeah, should be good. I'll go ahead and put a comment box here since this is a little bit strange. Drop the left half of the quad, right half of the quad, or both halves based on the result of check, the results of check move down. Oh, by the way, you press the, you can highlight things and then press the C key on the keyboard to create a comment box around something, which I should be probably doing more of these, but my hope is that my function names and event names are self-descriptive enough that, you know, you don't need comments for most of it. But that's where the, you know, descriptions and tooltips are helpful. The sort of like pseudo comments, and then you can even comment individual nodes in the graph like this if you're using a node, you know, unconventionally, or you want to make a note to yourself for future reference, or just anything that would warrant a comment in any other programming language, you could do that there. And this is like a block for like a pseudo function, or breaking out the functionality of your blueprint into discrete portions in different areas of the graph. And there's multiple ways to document things, whether it's these block comments or individual node comments or tooltips. So that's the splitting functionality working.